All right, for assignment number 30, this one will take us a little while to get through. First problem is just a quick pre-calc thing. Solve for x accurate to three places. We don't need decimals for the first one. There's a property that says e to the natural log of x is equal to x. So x equals 4. For the second one, because this says x accurate to three decimal places, that tells me we're allowed to use a calculator. So you should just solve by graphing. So for this one, I graphed to my calculator. I did zoom standard, just found the intersection point. Okay. But I do want to remind you how to solve this algebraically. So I would I'd multiply the 1 plus e to the 2x over to the left side or over to the right side, but then I would divide by 2. So this is 2,500 minus 1. So 2,499 equals e to the 2x. Then we can natural log both sides. And remember, the natural log of e to the 2x, the natural log and the base e cancel out. So that's just 2x. So the exact answer is natural log of 2,499 divided by 2. Or, again, you could just get the decimal version of that. It is much faster to solve by graphing. So if you are allowed to use a calculator, definitely do it that way. What about matching these graphs? Matching graphs doesn't usually seem that hard, although it might be hard to decide if we're not familiar with the equations between A and B. So it says assume that A and C are positive real numbers. So we don't have any negative coefficients to worry about here. Let's look at 25 versus 26 because those are definitely exponential functions. So we're deciding between C and D. And C times e to the ax, where remember C and A are both positive, that has to be exponential growth. So that has to be graph C. And then having a negative exponent when your base number is bigger than 1, that has to be exponential decay. So that's got to be D. So we're down to A and B for the next two. And I can't remember if we have talked about, I don't think we have yet. I think it's chapter 6 where we talk about logistic curves. But this is the equation of a logistic curve. So I do know that 28 is going to look like B. But say we don't know that. How are we supposed to work through these? You can go with y-intercepts. If you plug in 0, do you get 0 or do you get 1? I think on my answer key, I was looking at limits, which I still think would be good to do. But let's check out y of 0. That's probably a lot more efficient. C times 1 minus, let's rewrite this, 1 over e to the ax, so e to the 0. I guess it doesn't matter because you're plugging 0 in. So here I get 1 minus 1. So yeah, y to the 0 is 0. So that's got to be a. I was also looking at limits though. The limit, this is good limit practice. As x approaches, let's do negative infinity, of y would be c times 1 minus 1 over, what do I get if I plug in negative infinity? I get, actually, let me not do the 1 over thing. If I plug in negative infinity to this, I get e to the infinity. So that's 1 minus infinity. So that is negative infinity, that limit. And that's also what the graph is doing versus the graph here that's going to 0. All right, and then 28 similarly would be, by process of elimination, it's B. But if you plug in 0, let's just do this. You get C over 1 plus e to the 0. You get C over 2, and we don't know what C is, but it could be that comes out to 1. So you get something that's not 0 is basically the important part. Okay, for the next two, find an equation to the tangent line at the point 0, 1. So remember, find the equation to the tangent line means you need a point, which we're given, and a slope. The slope will be dy dx evaluated at 0, 1. That means we need dy dx or we need y prime. Y prime is just e to the 2x chain rule times 2. And y prime of 0 is 2 times e to the 0. So that's 2. So my tangent line equation is y minus 1 equals 2 times x minus 0. You don't have to write the x minus 0 part. You could just write 2 times x or 2x plus 1, whatever. I'm just going to be lazy and leave mine like that. For part B, the point is still 0, 1. The slope is still going to be what's y prime of 0. It's y prime that changes a little bit. It's e to the negative 2x times chain rule, negative 2. So y prime of 0 for this one will be negative 2 times e to the 0, which is negative 2. So y minus 1 equals negative 2 times x minus 0. Find the derivative. So here's a nice quick one. F prime is e to the 2x times 2. That's all for that one. This one will take a little more work. I'm going to make it like, I'm just going to think of it as 1/2 times e to the x minus e to the negative x. That's, you don't have to do that. I just like that better. So what would y prime be? So 1/2. And then in here, the derivative of e to the x is e to the x minus the derivative of e to the negative x is negative e to the negative x, because it's e to the negative x times the derivative of negative x. And we should clean that up. Y prime is equal to e to the x plus e to the negative x over 2. What about 57? Remember to use product rule. You don't want to get into a mistake of like just doing derivative of this times derivative of this. So product rule. So y prime should be first times derivative of the second. So derivative of sine is cosine. Derivative of cosine is minus sine. Plus the second times the derivative of the first, which is just e to the x. I just want you to be able to clean this up a bit. So say we factor out an e to the x. That would leave us with cosine x minus sine x plus sine x plus cosine x. So the signs cancel out. You have 2 of these guys. So y prime would equal, there are 2 of the cosine x's, but I'm going to write 2 e to the x cosine x. I just like having my answers in that order. You're not required to simplify it, but you will probably be looking for the multiple choice answer in which they simplify. Number 60, this is good practice with our second FTC, second fundamental theorem of calculus. So remember, this says that if f of x is equal to an integral of some constant, some function up here or variable, quick reminder on this theorem, then f prime of x, the derivative will cancel out the integral. The g of x will get plugged into the function, so f of g of x. And then you'll need to remember to multiply chain rule by g prime of x. I have a proof for why that happens in our notes in chapter 4, or you can come into office hours for a quick little explanation there. I just don't want to make this video longer. So f prime of x is equal to, so we're going to plug this in. So it's the natural log of e to the 2x plus 1. And then we multiply by the derivative of e to the 2x, which is 2 e to the 2x. And you could clean that up. I'm just going to leave it like that. All right. Use implicit differentiation to find dy dx. So we need to take the derivative with respect to x of both sides. We're going to have to use a little product rule right here. But let me write out my work first. Excuse me. All right, so product rule right here. So first times derivative of the second, chain rule, dy dx, plus second times derivative of the first. So that derivative's done. And then derivative of minus 10x is minus 10. Derivative of 3y is plus 3, but it's got a dy dx. And the derivative of 0 is 0. So let's see. Let's get our dy dx's together. Ooh, sorry. So I'm keeping the dy dx's over here and factoring them out. I would add 10 and subtract e to the y. And then we can divide. So dy dx is equal to 10 minus e to the y over x e to the y plus 3. And that's as far as this needs to go. For number 70, same idea. Start by taking the derivative with respect to x of both sides. All right, so what's the derivative of e to the xy? It's e to the xy. But then we need to do chain rule times the derivative of xy. So the derivative of xy, that's product rule again. That's first times derivative of the second plus second times derivative of the first. So that's the derivative of e to the xy. The derivative of x squared is 2x. The derivative of y squared minus y squared is minus 2y dy dx. And it's equal to 0, derivative of 10. Now, in order to solve for dy dx, I'm going to have to distribute this e through. So I'm going to write it as x e to the xy dy dx plus y e to the xy plus 2x minus 2y. And then this is totally up to you, personal preference here, but I'm seeing that my non-dy dx terms are positive, so I don't really want to subtract them over. I would rather keep the non-dy dx terms over here for this one. And then I'm going to add the 2y term over and subtract the x e to the xy term over. And then, like we've done a lot of times, I don't really want to show the separate step here. Factor out dy dx. Okay, so you would have y e to the xy plus 2x divided by what we would have in parentheses 2y minus x e to the xy. And that equals dy dx. If you kept dy dx on the left side, just distribute a negative through the top and the bottom of mine, and we would have equivalent answers. All right. Excuse me. So, okay, find an equation of the tangent line to the graph at the given point. So, again, to write an equation for a tangent line, we need a point, which we have, and a slope. The only reason I'm kind of obnoxious about doing this, writing this out every time, is because the number of times over the years that I have graded practice AP exams and students have only found the slope and not written the equation of the line just blows my mind. And those are such easy points to get. You don't want to not get the point just because you overlooked something or forgot to do it. So that's why I keep writing this, and you should too. Okay, find dy dx. Because I cannot simply solve this for y, I'm going to differentiate with respect to x. I'm going to use implicit on both sides. Oh, but instead of doing 1 over xy and then having a product rule, let's expand the natural log of x times y. It's the natural log of x plus the natural log of y. So that's great. And I don't think I'm going to do anything here. I could make this e to the x over e to the y, but then I'd have to do quotient rule, and I don't think I want to do that. So we'll just deal with that in a minute. All right, so what's the derivative of 1? That's 0. Derivative of ln x is 1 over x. Derivative of ln y is 1 over y dy dx. The derivative of e to the u is e to the u times u prime. So what's the derivative of x minus y? The derivative of x is 1 minus the derivative of y dy dx. All right, and just kind of like on the previous problem, to get the dy dx out of here, I need to distribute. So nothing to do but rewrite the left side. This becomes e to the x minus y times 1 minus e to the x minus y times dy dx. I'm going to add this term over here. So the 1 over y dy dx is already over there. We're adding e to the x minus y dy dx. This e to the x minus y was already over here, and I'm subtracting 1 over x over. I am not going to work too hard to simplify this, so I would have factored out a dy dx, which would leave me with 1 over y plus e to the x minus y in parentheses. So I'm going to divide that over here. I'm not going to worry about the complex fraction because I don't want to mess up while I'm simplifying. I don't want to do some silly algebra mistake here. Remember, we're not trying to find dy dx, really. We're trying to evaluate dy dx at a point. So once you get it to a place where you've isolated dy dx, just start plugging the numbers into it. You don't need it to be, it's okay if it's a complex fraction. We can plug in numbers into that. So this becomes e to the 1 minus 1 minus 1 over 1 over 1 over 1 minus e to the 1 minus 1. No, wait, not minus, plus e to the 1 minus 1. So I get 1 minus 1 on top is 0. 1 plus 1 on the bottom is 2. That would have been a problem if I had 1 minus 1. And I get 0 overall. If I had 0 over 0, I would have something that's indeterminate, right? So I would have had to work on something or simplify something or figure out what was going on if I got 0 over 0. So luckily I did not. All right, let's see. The next one, okay, this is our longest problem. Use a graphing utility to graph the function. So here's our graph, spoiler alert. There's definitely a change in concavity. There's definitely a relative min, a relative max. Find the extrema and the points of inflection, if they exist. All right, so find the extrema first. You should know that that means first derivative test. So find the first derivative. I need to use product rule. First times derivative of the second plus second times derivative of the first. We're going to be setting this equal to 0, so clean it up a bit first. I'm just trying to kind of get rid of my extra parentheses here. All right, what can I factor out of this? Because remember, for critical numbers, relative extrema, we're looking for where f prime is 0 or undefined. So let's factor out, we can factor out a negative x e to the negative x. They both have that. Makes this positive x. Makes this minus 2. And then finally, because I want to consider undefined values too, let's move the e to the negative x down to the denominator, so it's just e to the x. All right, so what are the critical numbers where we might have relative extrema? It's where f prime equals 0, so x equals 0 or 2. Is f prime ever undefined? Is e to the x ever equal to 0? No, you can't take a non-zero base number and raise it to an exponent to get 0. Or similarly, you can't take the natural log of 0 if you want to solve for that. So there are no undefined values for f prime. We're going to put 0 and 2 on a number line. So say we plug in negative 1. We would get positive 1 times 1 minus 2 over e to the x is always positive, right? If you put in negative values, you just get really small fractions, but I'm just going to write a plus sign there. A negative over a positive is a negative. If I plug in 1, I get negative 1 times, when I plugged in negative 1, I would get negative 3 right here. Okay, so try that again. It's still negative there. When I plug in 1, I get negative 1, and then 1 minus 2 is negative 1 over this always positive. That's a positive over a positive. And if I plug in 3, I get negative 3 times 3 minus 2 over this always positive, so negative. So f goes decreasing, increasing, decreasing. Remember, AP graders will not grade this section. This is just for you. But this tells me that there's a relative minimum at 0 and a relative max at 2. It says find the extrema, so I'm going to plug in 0 and see what f comes out to. F is x squared times e to the negative x. So 0 squared is just 0. F of 2. 2 squared is 4 over, since it was e to the negative x, over e squared. So 0, 0 is a relative min because f prime changes from negative to positive. 2, 4 over e squared is a relative max because f prime changes from positive to negative. Write out the words negative and positive on the AP exam, please. Excuse me. Okay, what about points of inflection? For points of inflection, we need the second derivative. So second derivative, I want to go back from this line here. And I think I want to do it like this. Like, I'm trying to think of what would be the easiest thing to use. I'm going to have to use product rule or quotient rule. It'd probably be easiest if I bring e to the negative x back up. But then I think I'm going to distribute this negative x through and make it 2x minus x squared. So all I did was, like, back here, it's like as if I just only factored out the e to the negative x. I think this is just what I think I want to take the derivative of. I think that would be the easiest setup. All right, so the second derivative is the first times the derivative of the second plus the second times the derivative of the first. Let's clean that up. Actually, I'm just going to factor out a bit. I can take out an e to the negative x. That leaves me with 2 minus 2x minus parentheses 2x minus x squared. So what do we have up here? We have a positive x squared. Negative 2x minus 2x is minus 4x. There's a plus 2. Let's send e to the x to the bottom. E to the negative x to the bottom. All right, what are the possible inflection points? What are the pips? E to the x is never equal to 0. So, and this doesn't factor, but let's do quadratic formula. Because if it's a real number, I need to include it. So 4 plus or minus square root of 16 minus 4 times 1 times 2 over 2 times 1. This is square root of 8, which is 2 radical 2. Reducing everything by 2, I get 2 plus or minus radical 2. Okay, and then don't overexert yourself when you're trying to think about how this is going to come out as far as testing. Remember that e to the x is always positive. So I'm not really going to plug numbers into this. I don't really want to have to rack my brain about, like, well, what's between 2 minus radical 2 and 2 plus radical 2. Not that we can't do that, but you just need to know if the denominator is positive. You just need to know when the top of the fraction is positive or negative to see where the signs change. And x squared minus 4x plus 2 looks like this. This is not what the f double prime graph looks like. It gets divided by e to the x, but this does represent the sign changes, that it's positive, negative, positive. And that means that there's a change in concavity at both of those values because the second derivative changes signs. I'm not going to simplify these ordered pairs at all. I'm just going to write 2 plus or minus radical 2. And what would f of that be? F was that quantity squared times e to the negative that quantity. This is very lazy of me, but I don't think they would have us really, we're not going to have something that ugly, I would imagine, on the AP test. Those points are points of inflection. Why? Because f double prime changes signs. Doesn't matter what it changes to, it's just the fact that it changes signs. Like I said, definitely our longest problem. And then graph this to verify. So I double checked like where was 2 plus radical 2, and that was right about here where this graph does seem to change concavity. All right, the value of an item t years after it's purchased is this function on the interval 0 to 10. Graph this. So remind you how to do that just in case. Okay, that's okay. I'll erase this. I was just thinking I really don't want to have to retype all that, but that's okay. 15,000 e to the negative 0.6286x. Set the window 0 to 10. And then zoom fit, which is option 0. So that's how I got the graph to show up. Find the rates of change of v with respect to t when t equals 1 and 5. So let's assume a calculator is allowed since they just told me to use one for part A. If there's a calculator allowed, even though we can find the equation for v prime of t, we don't need to. We don't want to mess up doing it, and we don't want to waste any time. So I'm just going to use my calculator just like I would for the AP exam and just say, okay, v prime of 1 is about equal to, and I'm going to let my calculator do the work. Now remember, you have the equation here in y1. Oh. Okay, you should have the equation in y1. I did not mean to hit clear. I want to type it in. What I was trying to do was quit to my home screen. So if you were on y equals like me, don't press clear. Second mode to quit. I would like to find a derivative. So math, 8, and deriv with respect to x, alpha trace y1, and plug in 1. So let's round this to 3 places. Negative 5028.844. And what's v prime of 5? So here's a good thing about this. Grab that, change that to 5, call it a day. That's about negative 406.891. Okay, and then part C says use a graphing utility to graph the tangent lines to the function when t equals 1 and t equals 5. Now, in order to get tangent line equations, I have the slopes, but I need the points. So I need to know what is v of 1 and what is v of 5. Now, if I want to be really accurate, and maybe I do, I don't know. I could just say, okay, one of the tangent lines is going to be, actually, maybe I will do this. I wrote out what v of 1 was in its decimal form on my answer key, but why don't we just do this? Y minus v of 1, whatever that came out to, is equal to the derivative at 1. Okay, those I did write out, so I'm just trying to not write as much work as I just don't want to write as much work. And then this is going to be t minus 1. And then the other one will be y minus v of 5. And that will be equal to, I know I'm rounding these, but again, just for the visual, honestly, it does not make a huge difference. If I wanted to be really thorough, I could put this expression into my y equals. I think I can do the whole like function notation thing in here. So we're about to find out. So negative 5028.844 times x minus 1. And then we would need to add this v of 1 value. So y1 of 1. Let's see if it likes that. Oh yeah, it graphed. Okay. And then, so I'm just going to do that too. So then negative 406.891 times x minus 5 plus y1 of 5. There's the other one. And that matches my little screenshot here. I think I took the window down a little further so you could see. But yeah, that's it. All right, find the indefinite integral. These are both pretty common integrals to see for our AP exam. So we need to use u sub, choose the one in the denominator. when you have e's floating around here. So u is going to equal 1 plus e to the negative x. Du dx will be negative e to the negative x. And if you need to solve this for dx, go right ahead. That's going to make this the integral of e to the negative x over u times du over negative e to the negative x. So the e to the negative x's cancel. This negative I'm just going to pull outside of the integral. So it's negative integral of 1 over u du. That's negative natural log of the absolute value of 1 plus e to the negative x. The absolute value plus e. The absolute value is not necessary here because e to the negative x is always positive. Adding 1 is positive, so just FYI on that. And that's it. That's as far as I have to go with that. When trig is involved, you usually let u equal the thing inside of the trig function. So we're going to let u equal e to the negative x. Du dx will equal negative e to the negative x. Du divided by negative e to the negative x will equal dx. Same thing on this one. So you're going to get e to the negative x, tangent of u. Instead of dx, you're putting in du divided by negative e to the negative x. E to the negative x's cancel again. I get a negative on the outside because I'm bringing it out. Tangent of u du. Now, if you have the integral of tangent memorized, then you can get pretty much right down to the answer. If you're like me and you don't quite have it memorized, we can do sine u over cosine u. It might be worth memorizing this. I just haven't taken the time, to be quite honest. So I'm going to make this, I don't want to use u again because I've already used u. So let's use something else. I'm going to use w. W sub. So w is cosine u. dw du is equal to negative sine u. dw divided by negative sine u equals du. If you don't like all those u's and w's, pick whatever letter you want. All right, so what do we have? We have a negative integral sine u. I subbed out cosine u for w. Instead of du, we have dw over negative sine. Sorry. Okay, so these negatives are going to cancel along with the signs. So now we're back to just integral of 1 over w dw. That's natural log of w, which was cosine of u. And remember, u was e to the negative x. So that's kind of fun. Plus c. But again, in our notes, we did say, oh, hey, the integral of tangent is negative natural log of cosine. The integral of tangent u is negative natural log of cosine u plus c. So if you memorize that, then you can get right down to it. You don't have to show all this work. All right. Last couple problems. Evaluate and then use a graphing utility to verify your result. All right, so I need to u sub on this one. Oh, my pen stopped working. All right, I need to u sub on this one. U is negative 2x. Du dx is negative 2. Du divided by negative 2 is dx. So now we have the integral from 0 to 1 of e to the u. Now dx is going to be du divided by negative 2. So I'm just going to put the negative 1/2 out here. And then I get negative 1/2 times it's e to the negative 2x. You're going from 0 to 1. Before you plug numbers in, I would suggest rewriting the negative exponent because I have found that if I don't do that for myself, sometimes I miss the whole fraction part of it, the fact that it's going to be a fraction. So just my suggestion. So you get negative 1/2. Plug in 1, you get 1 over e squared minus 1 over e to the 0 when you plug in 0. So that's negative 1/2 times 1 over e squared minus, this is just 1. That's my answer. I confirmed this on my graphing calculator, so I just did the straight up integral and got this. Negative 1/2 times e to the negative 2 minus 1 is the same decimal. For number 124, we're going to let u equal the denominator. The derivative with respect to x should equal negative e to the x. And so du divided by negative e to the x is going to equal dx. So on this one, we've got the integral from 0 to 1. So let's see. I've got e to the x over u times du over negative e to the x. So the e to the x is cancel. There's a negative sign out in front. The integral of 1 over u, so this is going to be negative natural log of absolute value of 5 minus e to the negative x from 0 to 1. That's the natural log of 5 minus 1 over e. Oh, wait, is it negative x? Sorry. Let's see. 5 minus e to the x, yeah. Not negative x. Okay, so that's going to be when I plug in 1, 5 minus e. That's a positive value, so I didn't keep my absolute value around it. Minus natural log of 5 minus e to the 0. So this is negative natural log of 5 minus e. This would be plus natural log of 4. And I just condensed this in my answer key because that's, if this were a multiple choice problem, they would probably condense it. So if you're subtracting these two, whatever was getting subtracted ends up in the denominator of the result. And then you can check this work algebra, or on the calculator, I mean. So I took the integral and got this decimal. And when I tested my condensed version of my answer, I got that same decimal. All right, last problem here. So I have both trig and an e. So the inner function there is inside of the e function. So I'm going to go with that as my u sub. So u is equal to the sine of pi x. Du dx is equal to the derivative of sine is cosine, pi x. The derivative of pi x is pi. So du will equal pi, divided by pi cosine pi x will equal dx. So this is the integral from 0 to pi over 2 of e to the u times cosine of pi x times du divided by pi cosine of pi x. So the cosines cancel. You're going to have a 1 over pi that you're going to pull out here times the integral from 0 to pi over 2 of e to the u du. So 1 over pi, the integral is e to the u, which is e to the sine of pi x, evaluated from 0 to pi over 2. This is a weird one. When we plug in pi over 2, we get e to the sine of pi times pi over 2 is pi squared over 2, so that's not like a value that we just can simplify that we know, minus e to the sine of 0. Now sine of 0 is just 0. So this is 1 over pi times e to the sine of pi squared over 2, just minus e to the 0, so minus 1. If I check the math on this, I get the same decimal whether I do the integral or I plug in my answer. Okay, that was a really long assignment and took you through lots of calculus, lots of u sub. Please come into office hours if you had questions on any of this or if you want more practice on any of these types of problems.